Hello, long time no see. This is video 35, and this is a big one. You might want to highlight this in your notes. A big what? A big statement in Python that does a lot of stuff. We'll be using these all over the place. Assignment statement. ASSIGNMENT STNT. Assignment statement. The format for this. The pattern that it has to fit. A variable, and I'll put that in pointy brackets. It's not literally the word variable itself. That means you've got to fill in that blank with a variable. A single equal sign, and on the other side, another pointy brackets thing, expression. Variable equals expression. The effect of this. Two parts. Part number one, the expression, in pointy brackets, whatever we filled in the blank with for the expression. The expression is evaluated by, we know who, by the CPU, because it's the thinking part with the ALU inside it. And then its value, well, it being the expression, not the CPU's value, then its value becomes pause dots part two. The new value of variable in pointy brackets it wasn't very pointy, was it? There, that's pointier. The new value of variable, comma, completely wiping out any old value that was there. It's gone forever. There's no way to get it back. Wiping out the old value of variable. There's a couple of things to highlight here. First of all, this is so important. How important is it? It's so important I'm going to read it back to you, even though I read it as I was writing it on the board. Here's what it looks like. It's always going to be just a simple thing here. It's going to be a single variable and nothing else on the left equals, and then expression. Expression could be wild and crazy. 6 plus 9 divided by 17 plus another variable and all that stuff. So there's a lot going on possibly on the right-hand side. The left-hand side always has to be one and only one variable. So here's what happens. The expression over here is evaluated by the CPU while your program is running, and then its value becomes the new value of variable, completely wiping out the old value of variable. Now, I'm going to even annotate this format up here. Number one, here's something you've really got to concentrate on and commit this to memory for the rest of your life. When you hit an assignment statement like this, and the clue to clue you in is it's going to have a single equal sign in it. Start on the right. It's like Arabic, or I think that language is right to left, isn't it? We start on the right if we're trying to figure out what the CPU is going to do with this, evaluate this, and then we look to see where it's going to go. There's step two. Number one, evaluate the expression. Then step two, then its value becomes, and we look on the left and see where it's going to go. Now, that is only going to make limited sense until we look at, you guessed it, some examples. And here they are. Examples. And away we go. Red, it doesn't look red, it's dark green. Red equals 10. Fits that format. The variable is red. The expression is 10. Now, let me stop right here. I couldn't just put this, I'm so excited I can't even talk. I couldn't put this around the other way and expect it to do the same thing. I can't say 10 equals red. That would just be foolishness. I can't assign a value to 10. First of all, it's not a variable. And second of all, 10 is 10. It can't change value. It's permanently 10, the number 10. That's what we in the biz call a literal value. You can't change it. Okay, I've gotten way too much mileage out of that. Green equals what? Red plus 10. What else we got? Red equals red minus 2. Blue equals green plus red slash 2. The slash means divided by plus 5. And there might be more statements. Maybe I'll add some more. Right now, though, let's just do what's called a trace of this. A trace is when you pretend that you are the computer using your memory and your ALU and your processor and pretend like you're executing this program just the way the CPU would do it. So what we got to do is one line at a time. Remember, a program is a sequence of statements. I can't pick out the one I think, well, you know what? Red equals red minus 2. That looks interesting. I think I'll start there. Nuh-uh. It's got to start at the beginning and go one line at a time in order, because the order makes a big difference. Red equals 10. Now that I've convinced you of that, I'm sure I have. Here's how I would represent this. Here's my convention. We know what a convention is. It's not required by the rules of Python, but it's a standard way of doing things, so we don't have to figure it out every time. Red. I indicate that it's a variable by putting a box, but since it's value, by very definition, a variable could change its value. I leave it open at the bottom so I can mark out an old value and put a new one in its place. So here we go. Red equals 10. Let's obey the rules. The expression. Let me see. Let me use my ALU and evaluate 10. 10 equals 10. Okay. The value of the expression is 10. Now I need to put that in the old, covering over the old value variable red. There is no old value variable red. This could be the very first line that uses red at all. So there's no old value to wipe out. It just sets red to be 10. The end. What about this one? This one ramps it up just a little bit. Pardon me. It starts on the right-hand side, step 1. Evaluate the expression. Well, how does it evaluate red plus 10? It has to look and see what the current value stored in memory, at memory location for variable red. What's the current value of red? Well, it's 10. Current value of red plus 10 more is 20. That's all of step 1. Then and only then will the CPU look at this and say, okay, now I've got that 10 plus 10 equals 20. Where do you want me to put it? Let's put it here. Let's put it here in variable green. Green. 20. Review. First we set red equal to 10. Then immediately, hot on the heels, we use the value of red that we just now put in there as part of an expression on the right-hand side of the next assignment statement. The value of red in that case was 10. 10 plus 10 is 20. The 20 goes in step 2, goes into variable green. Now, this is a weird one. If you were raised on mathematics speak and mathematics syntax, then this looks impossible. There is no number I could put in variable red where red would equal red minus 2. Oh, wait, maybe 7. 7 equals 7 minus 2. No, 7 is not equal to 5. Don't view this, regardless of how you arrived in this class, mathematics or otherwise, don't view this as like a statement of fact. It's not an equation the way you would see an equal sign used in math. Think of it as an activity. This is something for the computer to do. What does it need to do? It needs to do a little two-step here. It needs to do the right-hand side first. Red, the current value of red, minus 2. Now, it's got in its mind, in a register, the ALU is going to have the value of red, which is 10, subtract 2, that's 8. Visualize with me. 8 is sitting there in a register now. 8, what are we going to do with that? Store it back to variable red. Okay? This, it looks like that should have been enough. Subtract 2 from red. Except it's not. This is just an expression. This does not have the power to change the value of the variable red itself. It's just looking it up in memory. Go grab the current value of red sitting in memory and pull that in a register for me. It was 10 at the time we did that. So that 10 is sitting in a register, and 10 minus 2 is calculated. That's an 8. That subtraction all by itself does not change the value of red. If we want to change the value of red, we've got to do the 1, 2 up here and make that the new value of red. You got all that? That's a lot of pieces for one little statement here. This has a value, but it changes nothing. The change occurs when we do step 2 and store that result over here back in variable red, and boom, that's what makes that an 8 rather than a 10. Now your eyes deceive you. What you see here is the ghost of a 10. The computer cannot see that at all. Once we change the value of variable red to an 8, the 10 is gone forever. There's no way to get it back. There's no undo arrow. It says, I didn't mean to do that. Take me back to 10. It's too late. 10 is gone. 10 has left the building. Moving right along. Oh no, look at all this. You know what? I'm going to put notes down here for this. Green is currently 20. Red is currently 8. And 2 is currently 2, and 5 is currently 5. Now, here you could fall back on a little bit of mathematical expertise. If there's a mixed expression with division and multiplication, which is the star asterisk operator, plus and minus and all that, it goes through and does all the divisions and multiplications first. It's called order of precedence. Then it goes back through again and does any pluses and minuses, does any addition and subtraction. So the first part that's going to be done is this part. When it's evaluating this expression, even though it's in the middle of the expression rather than at the beginning. Red divided by 2 is 8 divided by 2, 4. Then it adds all these up, and it'll be 20 plus 4 plus 5. Let me see if I can do that in my head. 25, 26, 28, 29 becomes the value of variable blue. What did I say? 29? Short-term memory of a fruit fly. Is that right? Let's see. Red was 10. Green became 10 plus 10, also known as 20. Red got bumped down by 2, and that became the new value because it was on the left-hand side of the assignment. And blue equals current value of red. Now notice this wasn't 10, even though it was 10 up here when we used it. That's why we got to be so careful to do these things in order. This had a new value by the time we got down here. And it was 8. 8 divided by 2 is 4. 4 plus 5 is 9, plus 20 is 29. Done and done. And I might have enough room to slip in stuff that I was saying, hand waving style, without making it official. Here it's official as an aside. Arithmetic operators, A-R-I-T-H-M-E-T-I-C operators. Plus means addition. Surprise, surprise. It could also mean positive. If we just put plus in front of a number, it's like you're saying, I meant for that to be positive. I didn't accidentally leave off a negative sign. So it could mean addition if it's between two numbers. It just means plus if it's a number all by itself. Okay. Minus means subtraction. Ho hum. What else we got? Star or asterisk. I like star better because it's easier to say. That means multiplication. Slash, that kind of slash like I used here, that means division. We also got a weird one, double slash. 2 slashes in a row means integer division. Integer division means throw away any stinking remainder. Don't make it a decimal fraction. If red had been 9, for example, 9 slash 2 is 4.5, 4.5. Doesn't come out even. 9 double slash 2, you just keep the whole number part of the answer and throw away the remainder. So 9 double slash 2 would still be 4. It's not going to be 4.5. Integer division means only keep the integer part of the number. Don't even round it. If it came out to be 4.9, it would still be 4 if we were doing integer division. This is kind of an outlier. I put this in there to have sort of a complete list of multiply, divide, and so forth. But integer division, we're not going to see that terribly often. And the next time we do see it, I'll be sure and remind you what that is and how it's different. I just wanted to slip in my little table of them down here. There's a table of them. And assignment statement, that's a big deal. That covers the whole board, all these different colors. That's enough for this one. I'll see you online.